Hi everyone, this is topic number 7, find trigonometric functions on a unit circle. So as you can see in the right, you have a circle. Let me draw the axis here. It's a rough diagram, so don't judge my drawing. Now this is your x-axis and this is your y-axis. Let's say if we have a terminal side which makes some angle theta here, and this is the point x comma y. Okay, and if I say this circle is a unit circle, the radius made by this terminal side will be 1. Now in this case, this is your y coordinate and this is your x coordinate, right? Length. Now how we will find the cos theta? Now this is making a triangle. If you look closely, this is a triangle, right? This is a triangle, right angle triangle. Now from this theta, this is opposite, this is hypotenuse, and this is adjacent. We have done that already, but just a quick reminder. Now cos theta is what? Socato, you remember? So CAH, C for cos and adjacent over hypotenuse. Adjacent here is x, opposite is y. So x over hypotenuse is 1 in this case, because which is r, and radius is 1 because it is a unit circle. So cos theta will be equal to x, or you can write x is equal cos theta. Similarly, if you will do for sine, you will get y is equal sine theta. So when I say a unit circle, and if I give you some point, let's say for example point P 6 over 10 comma negative 8 over 10, then you don't have to worry about unit circle and anything. Just read the question that terminal side of an angle theta in standard position intersect the unit circle at point P, right? So in the unit circle it is intersecting at point P. So what you can do is point P is basically x comma y, and x is nothing but cos theta, y is nothing but sine theta for unit circle. So cos theta is equal to 6 over 10. Sine theta will be equal to negative 8 over 10. That's how you will find sine theta and cos theta, okay, for a unit circle. Let's try some more question. Now let me remove this circle because we will not need that. Okay, now next question we have this one. Now this point P is, the coordinates are negative 10 over 26, negative 24 over 26. Now we know that P is x comma y, and we can also write for a unit circle cos theta and sine theta, right? That's what we did. X is equal cos theta, y is equal sine theta. So cos theta will be equal to negative 10 over 26. Sine theta will be equal to negative 24 over 26. If you want to simplify, you can simplify. Negative 5 over 26 will be 13 because 2 is a common factor, and similarly for this, negative 12 over 13. You can write in the simplified expression. Next question. Now you have a point on a unit circle, square root 3 over 2, 1 over 2. You have to find cos theta and sine theta. So this time cos theta will be square root 3 over 2, sine theta will be 1 over 2. If somebody asks you to find theta, how will you find? Theta is equal cos inverse root 3 over 2. Just substitute in the calculator, you will get your answer. And theta is equal sine inverse 1 over 2. Right? Next, question number 12. Now we have a point P which is square root 6 over 5 comma square root 19 over 5. You have to find cos theta and sine theta. So cos theta is square root 6 over 5 and sine theta is square root 19 over 5. That's how you will solve trigonometric functions on a unit circle. That's how you will find. Okay, next question we have. In the next type of question, we have to find the period of each function. What we have to do is find the period of each function. So if you remember, how do you find the period? So let me quickly explain. If you have y is equal a cos b theta, if this is your equation, then the period is given by 2 pi over mod b, right? Or else you can say 360 degree over mod b. That is your period. So what we are doing, we are taking only this from here. So for example, if you have y is equal 2 cos 2 theta, then what you will do, period will be 2 pi over mod 2, or you can say 360 degree over mod 2, which will give you 180 degree. Now this is when you have expression. Now what about the graph? If you have the graph, for example, this is your graph and it's going like this. Now the period is when the one cycle complete, okay, and after that it start repeating itself. So let me just draw it again because I will show you the repetition. Okay, it's not looking uniform, so don't mind that because I'm just doing the rough drawing. Now if you see here, let's say this is 0, this is pi, this is 2 pi, 3 pi and 4 pi. So what will be the period for this one? So one complete cycle is from 0 to 2 pi, and after that it is repeating again, right? So the period will be 2 pi. That's how you do it. After that it is repeating again. So after each 2 pi it is repeating itself. That's how you see from the graph. So let's take first question. Now the first question is, I will have to draw. So I will do the rough drawing, so don't mind my drawing, just try to understand the concept here. Okay, let me take a different color. Okay, 0, then we have 2, we have 4, 6, 8. This is your x-axis, this is your y-axis, and now this is coming somewhere here. I'm just trying to do the rough drawing. So that's how this graph is. Now if you look at this graph closely, where do you think it is repeating itself? Where do you think it is repeating itself? Now if you look from here, this is going from 0 and this is somewhere around, let's say this point is in the middle, so let's say this is 3. So if you look at this structure from this point 0 and it is coming here up to 3, so this is completing one cycle here, right? And then after that again it is doing the same cycle and then again doing the same cycle, right? So here if you look, the period is 0 to 3, so the distance here is 3, and then it is going up to 6, then it is crossing from 9. So the period is 3. So you will have to check where the shape is repeating itself, okay, where the one cycle is completed. Now next question. In the next question we have, okay, again now let me just do it quickly. 2, 4 and 6, 8, 10, 12, 14, okay, 16. So what is this shape is? It's just going up to 2 and then 4, coming down in between. Okay, so that's how, something like this is the shape. Now if you look at this shape where it is repeating itself, now this is your 0. It started from here, right? And now again it came down to this point. Is it one complete cycle? No, then it is here, because I started from this point, so this point it started going up. So the next point should be this one. It is going up again, right? So this is your one complete cycle. It's going up, maintaining, then coming down, and then maintaining at this point. So this is somewhere at 8. And if you look here again, this is going up, maintaining itself, coming down, and then it is coming up to the 16, right? So this is 8, this is 16. So what is one cycle? One cycle from 0 to 8, so the period is 8. That's how you will see it from the graph. Okay, for the next two questions, let me tell you the answer quickly. We have this graph. It is going, okay, 0 2 4 6 8 10. Okay, so that's how the graph is. Now in this one, it is starting, let's say, from this point. Okay, this is 0, and where it is repeating itself, this is going up and then maintaining here, right? So I'll have to check another point from where it should start going up, right? So that point is here, and after that it is doing the same repetition of the shape. So this is somewhere around 12, right? So if this is 12, then the one cycle is from 0 to 12. The period is 12 for this shape. Next question. I'm doing the rough drawing, so just try to understand the concept. So you can try with different type of shape in your book. Okay, that's in this shape we have. So this is your shape. Now this point is 0. This is around 2. This is somewhere around 4. This point is 6. This point is somewhere around 8, 10, and 12. So now you can see where it is repeating itself. So do one thing, try this by yourself and tell me the period for this function. Okay, or else check it by yourself, where is the cycle ending, right? That's it for this video, and see you in the next one.